Folks, when I wake up and I'm not feeling all right, I grab myself some of these pills and get working well. Oh, my bad. Wrong virtual conference. I'm going to bring up Pushkar right now. How you doing, dude? What's happening?
Hey Demetrius, I'm doing great. How are you?
I'm great. I am excited for your talk as always. I know that we've had quite a few of your talks in the MLOps community and on the virtual conferences, and they never disappoint. So I'm just going to get out of the way, and I'll see you back in a few minutes.
Hey everyone, my name is Pushkar Garg. I work as a staff machine learning engineer at Clari. And today I'm here to present on the topic of how we built a data lake for the enterprise use case. So yeah, let's get started. So a little bit about Clari. So Clari is something which started as a revenue forecasting company and is now evolved into a revenue orchestration platform. And we use AI to generate insights for the deals in the pipeline that any of our customers may have. So the business need for building a data lake was that we needed a centralized, scalable data repository for our AI and ML workloads and then integrating with the data sources from the acquisitions that we've had over time. That seemed like a good idea to do for our AI to be even more accurate, so that we do have insights from other data sources that we've acquired over time. The primary data sources that we use to ingest data are RevDB. So RevDB is our state-of-the-art revenue database that is populated using the upstream CRM systems, for example, Salesforce, that contain the data about these deals and about other information about the customer's sales. We ingest that into our RevDB, and the other data sources are MongoDB. So every deal would have some kind of conversation happening around it, whether that is over Zoom, whether that is via emails exchanged. So those two additional data sources we needed to incorporate into our data lake. And then the key requirements for building the data lake were that we needed like reliable data replication with good data quality checks, support for schema evolution. So the upstream CRM systems, they work on a config, right? And then that config gets updated over time, and then that reflects as schema changes in RevDB. So we needed to be flexible to support those config changes in the upstream CRM systems, so that we still our AI workloads can still work without failures. And then one of the other use cases was that we wanted efficient querying. That the data that is persisted in RevDB may not be well partitioned for the AI/ML use cases, which is mostly based on timestamp. So we wanted to be able to recreate those partitions such that the querying of the data became more efficient. And then, being an enterprise company, obviously we want to have proper data governance and lifecycle management of the data available in the data lake. So going through the high-level architecture of what we built, we deployed an instance of Trino on K8 locally, and we built connectors with S3, with RevDB, which is deployed in Postgres, and MongoDB. And then we use Airflow for orchestration of the ingestion pipelines and the dynamic creation of ingestion pipelines. So our use case is that for every customer of Clari, we would have a different pipeline for ingestion, and then we use the managed instance of Airflow for orchestrating and managing those pipelines. And we use Trino to run queries, which give us the data, and then we persist that in the data lake in the form of Iceberg tables. And the downstream from the data lake happens via several different ways. First is we use SageMaker for running our training jobs. We use AnyScale for deploying the models, and then that's how the inference gets the data. using the data lake. And then most recently, we've deployed some AI agents like deal inspection agent, which also get data from the data lake for the bootstrap use case. So when an agent is going live for a particular organization, it would need all of the historical data for all the deals that may be in the pipeline. So that is powered by the data lake as well. In terms of going over some more details about the architecture, so we use S3 for the storage layer. We use Apache Iceberg, like I said, for as a table format to support schema evolution and then efficient querying. We use AWS Glue as the metadata store. And then what we've done is we create one database per org. That helps us with the lifecycle management of the data, and then also keeps the data lake as a multi-tenant store, but also isolated across different orgs. We use Trino as the query engine. So Trino has catalogs built for S3, for RevDB, for MongoDB as well. And then it also has a catalog built for the data lake. So any queries running on top of data lake are supported by Trino and Athena both. And in terms of the orchestration, we use Airflow for pipeline management, and we have something which is really interesting is the dynamic DAG creation. So our use case is that we need separate pipelines for each organization or each customer of Clari. So we use the same code and we use a config to add any new organization that may become a customer of Clari, or over the course of time, we need to run models and run insights, generate insights for a particular organization. So we do that dynamically, and we don't need to manually go in and create the ingestion pipelines. And then we have separate pipelines for ingestion and validation that helps us keep track of the data quality checks. In terms of ingestion modes, we have full refresh, which is to create new tables. So whenever there is a schema change, we create another table. We also have incremental updates. So based on if there is no change in the schema, we ingest and append new data since the last ingestion timestamp. So one thing that we identified was that building these ingestion pipelines, the ML platform team was becoming the bottleneck. So we decided to create self-serve APIs, which our customers, which are the internal data scientists and the machine learning engineers, they use to update the config file, which helps in creation of these ingestion pipelines. So in this example, a user can call this particular API to add an opportunity, to add the opportunity table to the org ID 401's ingestion pipeline. And then similarly, you can do that for other orgs as well. I won't go into the details of how that happens, but we have several tags and several databases involved, which ultimately result in the creation and updation of ingestion pipelines. So it's all democratized, and that's been one learning that that has helped with the adoption. And then finally, in terms of data quality and governance, we have validation pipeline, which does data quality checks, validates the row count between the source and the target, detects duplicates within the target tables, and then the results are stored within a dedicated management table for tracking. As any organization, we need to be compliant when it comes to data. So we have a high-level churn service, which involves the deletion of data if any org or if any customer of Clari churns. So we have integrated with that, and whenever there is a notification, the churn service sends out a notification in the case of churn, and whenever there is a notification, we go in and automatically delete the physical data in the form of files, the metadata from Glue, and then all of the ingestion artifacts for that particular org or customer of Clari. And then in terms of table maintenance, we do cleanup of stale table versions. We only keep the 2 latest table versions in available. And we have some retention policies for historical data. So anything older than 6 months gets deleted. And then we run optimize command from time to time to merge the small files into larger files so that the queries remain more efficient. Yeah, that's it. That's the lightning talk. Thank you.
Boom, that was lightning fast. If you can promise to answer this one in the next 2 minutes, I'm going to throw it at you. All right. So,
Yeah.
what technology are you using for the data lake warehouse itself? Or did I miss that in your slides?
Yeah, we are using Iceberg, and we are using Trino for the querying. We are using Iceberg for the data storage, and we are using Airflow, like I mentioned, for the orchestration of the pipelines.